Right now, your watch is talking to your phone is pinging your car, and your car is quietly bouncing signals off satellites in low Earth orbit. All of this communication happens in fractions of a second, entirely invisible to you, and completely without your physical input. Step back into a 1980s living room, and you find a strictly isolated environment. The television, the radio, the lamp, they shared the same physical space, but they had absolutely no awareness of each other. Environmental controls operated mechanically. To change a room's temperature, a hand had to physically turn plastic dials to trigger a switch. Even personal accessories operated in closed loops. A digital watch from this era performed exactly one mechanical function, tracking the internal quartz time. It had no ability to track your heart rate, and certainly no way to tell a thermostat you were feeling cold. For most of human history, the physical objects we built were entirely passive. They waited in silence for us to push buttons, flip switches, or turn keys. When the internet first arrived, it was heavily restricted by geography. To access the global network, you had to sit at a heavy, stationary desktop machine wired directly into a wall. By the late 1990s, engineers began looking at those wires and asking a difficult question. What if the network escaped the computer monitor and leaked into the physical environment? They called the solution the Internet of Things. The mission was to embed everyday tools with microchips, letting them collect and transmit data outward. Giving an object a data stream alters its basic utility. It takes a piece of dead plastic or metal and turns it into an aware, communicating node on a global network. By the 2010s, this concept aggressively entered the consumer market, starting right inside our homes. Everyday fixtures gained the ability to autonomously observe their environment. A doorbell became a motion-sensing camera capable of streaming live video directly to the internet. To manage all these scattered sensors, the smartphone emerged as the universal remote control. Lighting, security, and climate control were consolidated into a single touchscreen. A modern house operates as a habitable computer, continuously analyzing data streams to learn the daily routines of the people living inside it. A network designed to scale infinitely couldn't stay confined to the living room. Municipalities began embedding sensors into intersection cameras and roadbeds, tracking the physical movement of the public to dictate traffic flow in real time. This instant data relay extended into critical industries, replacing manual chart checking in hospitals with live second-by-second tracking of patient vitals across entire wards. This massive integration of self-monitoring systems into global manufacturing and logistics became known as Industry 4.0. At the macro scale, the isolated physical world has been paved over by an invisible layer of digital tracking. There is, however, a strict mechanical requirement for all of this to work. For a device to operate intelligently, it requires a constant, uninterrupted diet of user data. Your smartwatch can only warn you about a heart condition if it continuously extracts your biological metrics. Your car can only reroute you around a traffic jam if it constantly broadcasts your exact geographic coordinates. We are making a continuous, often unconscious trade-off, offering up the specific details of our daily routines in exchange for frictionless, automated convenience. We have built a physical environment designed to monitor and respond to our needs in real time. But as trillions of data points are harvested every day, we are left with a mounting tension. Who actually owns the rights to that digital history? Connecting physical objects was only the first step. Next, the network had to figure out how to digitize human value. For generations, wealth was heavy. It was built on coins, precious metals, and stacks of physical paper. But soon, trust in paper shifted into trust in cryptography. Next time, we explore the evolution of money and how lines of code became worth billions.